Step 5 in the ideal system redesign methodology is concerned with creating the ideal design. As theoretical background, the ideal design resides in conceptual space. We have talked about the information field, which resides in conceptual space. An ideal design is part of this. Its purpose is to inform or put form into the current system. And it informs the current system in such a way that it inspires it to behave in a new way and to move towards new outcomes, a new future that is more ideal than the current future. The ideal design is an idealized description of the state of the system, that is an end description, of the functions or activities or strategies of the system, that's its means, and then the outcomes that are being achieved by those functions. There are different types of ideal design. In the biomatrix, we distinguish different types of systems, activity systems, entity systems, and the web systems, subwebs. And accordingly, we can distinguish different types of designs. There's first of all the activity system redesign, that is the redesign of string-like systems like functions, projects, activities. They are all descriptions of activity systems. And that emphasizes the function, so what the activity is, and the outcomes that the activity achieves for its clients. Every activity system is directed at a specific entity system, and it does something or contributes to an entity system. And this should be described in an idealized form. So what are the ideal outcomes that I want to achieve for my clients, and how do I ideally go about it to achieve those? Then we have entity system redesigns. That can be a whole entity, like the whole organization or the whole person. It could also be a sub-entity, for example, a department or a business unit that is part of an organization. It is not an entity system in its own right, but we are looking more at a bundle of activity systems from an entity system perspective. In the context of an individual, we call it a role. We are looking at the role of a person as a parent or as a worker. And it typically consists of more than just one function. It could also refer to an incomplete entity system. As we have explained in the first module, artifacts, technological artifacts, etc., are incomplete entity systems. But they can also be designed according to ideal system redesign methods. What do we emphasize in the context of an entity system redesign? Well, we emphasize, first of all, the state of the system. That has to do with being. How is the nature or the being of the system? What kind of person? What kind of car? What kind of business unit? So it describes the state of the system as an outcome, and then it describes the interacting activity systems that it is involved in. So what kind of person am I is the state, and then what are my activities? And we speak of threefold activity systems. What outward-directed, inward-directed, self-directed activity systems do I want to contribute, and to whom do I contribute each of my activity systems? Who are my stakeholders in each of those activity systems? And how do I interface and balance these different activities? How do I structure them? And what should be the outcome of each of those activity systems. And we describe that in a more high-level integration in the context of an entity system. We are not doing that in this module. This is subject to the organization transformation program. And then we also have web systems. When we deal with complex societal problems, like for example poverty, then we will have many different activity systems and entity systems involved in co-producing poverty, and we need to redesign quite a few activity systems and entity systems in our society if we should not reproduce poverty again. And this is really a combination of both entity and activity system redesign. Only we are talking here about chains of activity systems and containing hierarchies of entity systems. And this is the subject of our societal transformation program. What are requirements of an ideal design in general? According to the general system theory, especially the ideal system redesign school, such as represented by Erkov, Jadaki, they say an ideal design should be technologically feasible. So we shouldn't make a design that is so ideal that we don't have the technology. And I mentioned that earlier, if we make a communication design, then telepathy is not technologically feasible. The design should also be organizationally viable. So we may have the possibility of new technology, but we haven't got the capability as an organization to use it. So then that is also not supposed to be part of an ideal design. To give a little bit a ridiculous case study here, once a group of persons brainstorming in the context of the transport system misunderstood the exercise, and they thought they should come up with crazy or idealized strategies as well, and not feasible or realistic ones. And they thought they're going to deal with traffic jams by getting helicopters to lift out the cars that jam. Well, technologically, this is a possible strategy, but organizationally, it is completely non-viable. So we would not allow a strategy like that to be included in our design. And the third requirement is that the system must be capable of learning and development, and that must be built into the system. Now, biometrics system theory and our methodology would agree with those 3 points and add maybe a fourth point, and that is the need to incorporate generic, systemic organizing principles. And those are the principles of biometric systems theory. For example, we would need to build the 7 forces of system organization into the ideal design and the coherence between those 7 forces. Or when we redesign an entity system, we are looking at the 3-fold organization of the entity system. So those are principles that are being built into the ideal design as well. What are the benefits of an ideal design? Well, an ideal design incorporates the values and expectations of all stakeholders. So a design always is a design for the system and its surrounding, in the sense of what the system wants ideally to contribute to its environment. It creates a consensus and alignment between the parts of the system and the system and its external and internal stakeholders, so the system and its environment. It also generates commitment and stakeholder cooperation, because if the system builds in that it is wanting to meet the expectation of its stakeholders. It will get the goodwill of the stakeholders and very likely enlist their cooperation, because it creates a win-win for itself and its stakeholders. It stimulates creativity, and that in itself can be a very good thing, to start a design exercise just to activate creativity in an organization, for example. And it enlarges the conception of what is possible. Very often, as persons go through an ideal design exercise, they change their worldview of how the world works considerably, and their vision or their perspectives get enlarged of what is and isn't possible. Eckhoff has expressed it very beautifully. In summary, what the benefit of an ideal design is. Idealized design reveals that the principal obstruction between us and the future we want is ourselves. So if we think low level, we get a low level future. If we think higher level, if we think win-win, then we are creating a future that is better for us as well as our environment. It really depends on us. What is the methodology of ideal design? The ideal design is created by a design team. And that team uses the brainstorming output as it is integrated in the notebook. It uses generic systems principles, such as we are going to learn more about in the next module and have already started to learn in the first module. And then categorizes all that information around a design framework. So it uses a systemic design framework with the fleshed out information from brainstorming and generic principles. The ideal design should also consider and possibly involve key stakeholders and incorporate their expectations as well, which of course is part of every systemic framework in any case, but still it is important to emphasize that. Tips for creating an ideal design? A list of strategies is not a design. A lot of people, when they brainstorm, think this, if one groups it a little bit together, like in a design notebook, that's the design. This is not the design. It needs to be iterated, and higher level patterns need to be identified, and those need to be lifted out into a design. A design is a much higher level integration than a design notebook. Creating a design requires a systemic framework to ensure the internal consistency of the design information. Creating a design also involves vision and creativity. It is more an art than a science. To translate the brainstorming output into a good, inspiring design is not easy, and it can take a lot of work and a lot of iterations. Large groups cannot do an integrated design. One never uses groups to make designs. One uses groups to generate ideas for a design, to brainstorm. For that, groups are very useful. The actual design team should not be much larger than maybe 5 to 7 persons at the most. Creating a design is an iterative process. One has to work through the information again and again to produce higher level outcomes, better formulations, more integrated strategies, and so on. And ideally, one would involve a widening circle of stakeholders to refine and iterate the design. So maybe the design team comes up with a core design, and then different stakeholders add, flesh out the design, change somehow the design. And the importance of the design team is in guiding the process to make sure that the design stays coherent and internally consistent. And as they are involving stakeholders to reflect on the design and help improve the design, They also create alignment around the design, which is necessary to enlist the support of the stakeholders in actually manifesting the design through implementing it. We will produce more detailed information in the next module, and you will also finalize the design in the next module. However, in the meantime, you should nevertheless do a first iteration of a design, even if it is incomplete. You will just flesh it out in more detail and add on in the next module. But in this module, you have brainstormed enough output to make a first iteration.